Let's talk about some real chemistry. The mass in grams of 1 mole, meaning 6.02 times 10 to the 23rd particles of a substance, has a name. It's called the molar mass. The unit for molar mass is grams per mole. We write it G/mole, but please don't say G/mole out loud. It just sounds so sad. Grams per mole, that slash is a per. The average atomic mass on the periodic table is the number of your molar mass. And at this point, we're going to talk about color coding to help you learn how to do mole calculations. I have invented a color coding system to kind of walk you through it. So what we're going to do is we're going to use yellow for grams. And I have like a little mnemonic device there that means a memory trick for golden grams. That's a cereal. Golden grams. I don't know if you've ever had it. It's freaking delicious. But I picked yellow for golden grams to help you remember grams are yellow. Particles, which for now is just going to be atoms. Later, we'll use other words for that. For now, we're just going to use atoms. But particles or atoms, we're going to color code blue. And my memory trick for you for that, when it's blue, you use 6.02. times 10 to the 23rd. When it's blue, use 6.02 times 10 to the 23rd. That number always goes with a blue word, which for now is just going to be the word atoms. And then in the middle, we have moles in the middle or green in between. Moles in the middle or green in between. Moles in the middle or green in between. The reason I went with this color coding system partially has to do with how colors work. I don't know if you've ever tried to mix yellow and blue together, but wherever yellow and blue touch, you get green in between. And guess what? Wherever grams and atoms touch, you need to have moles in the middle. And if you don't have moles in the middle, your math is not going to work out the best way for your units. Okay, so that's the basics of the color coding. We'll do that with the math as we go. I just wanted to introduce you to the colors first. And if you have your own colors, go ahead and take a second. And for the rest of this page, find your color words and go ahead and color code them anywhere they come up on this page. Just so you can get used to what color goes with what word. I know color coding is like so 5th grade, but I promise this actually helps if you do it diligently. I do this because I know what I'm talking about. You know, I've only been teaching for like 10 years, so teaching specifically chemistry that whole time. I know what I'm talking about. Just do the freaking color coding. Okay, I promise it'll help you. Or at the very least, if you're not doing it, don't let it be because you're lazy. Let it be because you're smart. But even then, even if you're smart, you should do the color coding. Okay. How to solve mole problems. Depending on who your teacher is, you may have something different inside of this box. But I'm the one making this video. So for this video, I'm going to use my stuff. If you have a different if you have a different chemistry teacher besides actually me who made the videos for this unit, well, they'll tell you what to put in this box if they want something different that badly. But I'm giving you what's called an algorithm, which is basically a problem-solving set of steps on how to solve mole problems. First, you always are going to end up color coding with your green and your yellow and your blue, whichever ones apply. All of those end up color coding the problem. Just start with that. Make your life easier. I promise it will make your life easier. Okay. Then you're going to write your given. Your given should be a number and a unit and an element. And then if you want to write it over 1, if that makes you feel better, you can. You don't technically need to write it over 1, but some people are more comfortable with fractions that way, which is fine. You decide how many fractions you're going to need and draw them. I'll come back to that when we do an example problem. You're going to write your unknown, which should be a unit and an element, on top of the final fraction. That's always where the unknown goes. And then I have a rule called what goes up must come down, which again, I will, as we do a problem, explain that to you further. Some tips to remember. Again, with your color coding, green is always going to be mole. Yellow is always going to be your number of grams. And blue is always going to be atoms. Eventually, we'll also use the word molecules there, maybe some other words. For now, we're going to just exclusively use the word atoms. Please notice, anytime you're using the word mole, you're going to use a 1. Anytime you're using the word atoms, you're going to use 6.02 times 10 to the 23rd. When it's blue, use 6.02. And I haven't technically taught you this yet. We will on the next page. But when you use grams, you're going to use a number from the periodic table. A couple other pointers. If you have a fraction with 2 colors, one color always needs to be green. You always have to have moles in every problem. So you can have a fraction that's grams over moles, meaning yellow over green. You can have a fraction that's moles over grams, meaning green over yellow. You can have a fraction that's moles over atoms, which would be green over blue. You can have a fraction that's atoms over moles, which would be blue over green. Any of those are allowed. Those are all fine. But if you have a fraction that is yellow over blue or blue over yellow, so atoms over grams or grams over atoms, you have left out moles. And you always need moles in one of your fractions. So that will tell you those are wrong. You cannot put fractions that do not have moles in them to convert. Okay, you have to have moles to convert. Blue and yellow never go together. Okay, and then at the end, check that you have 2 of each used color. Again, we'll do that as we go through a problem. So let's try one. If you have 4.6 moles of titanium, how much is the mass of your sample in grams? Start with your step 0, which tells you to color code. Just color code it. Find your color words. So I see the word moles, which is green, and I see the word grams, which is yellow. Okay, I color coded. That's not too bad, right? Step 2, write your given, which should be a number, a unit, and an element, over 1. If you read the problem, find the number they gave us, 4.6. It's got a unit with it, moles. The unit will always be a color word. It's also got an element with it, titanium. That is all together my given. And I'm going to write that whole thing, 4.6 moles of titanium. That is all together my given. I need to write the whole thing out. Again, some of you may be more comfortable writing this as a fraction over 1. You don't technically need the fraction over 1. If you're fine with calculating fractions in your calculator and doing all the multiplication and stuff without needing the over 1 there, that's fine. Some people like it. I just want everyone to have all the tools available to them. So you write your given over 1. That was step 1. Step 2, how many fractions and draw them. If you see the word moles, that means 2 fractions. And when I say 2 fractions, I'm including the given. So that's the given over 1 times some other fraction. If you see the word moles in the problem, that's what your problem needs to look like. The given over 1, you don't have to put over 1, but then times just one other fraction. So draw them. I did my given over 1 already. I need to draw my other fraction. Write the unknown, which will be a unit and an element, on top of the final fraction. That's step 3. So again, if you read the problem, how much is the mass of your sample in grams? Grams is my unknown. And the element there, we're actually still looking at titanium. And if we're color coding, I can see so far where my stuff is going, given over 1 at the beginning, ending with the unknown unit and element. And you can check that, oh, hey, we used green in our fraction because they gave us a green word in the problem. We used yellow in our fraction because they gave us a yellow word in the problem. If you're not matching up your colors, then that tells you you're doing something wrong. The colors are a way to help you check if you messed up somewhere. I need to plug in this laptop. Hang on a second. Peek behind the curtain. Here's what the rest of my family room looks like. Okay. Yeah. Now looking at our final step. What goes up must come down. Here's what I mean by that. We know that when we want to use a conversion factor fraction to convert, we want whatever words are up here to simplify out, which means we need to have those same words on the bottom somewhere. So I always say what goes up must come down to remind myself that when I'm organizing my problem and organizing my fractions, I want the words to match in those spots so that they can cancel out with each other or simplify out with each other. Just like if I was doing like 1/4 and I multiplied by 4/1, the ones would simplify with each other. We talked about that in that fractions video. This time I'm just simplifying with words instead. So I get rid of the moles, I leave myself with grams, which means that the unit of my answer is going to have to be grams because I got rid of the moles. They simplified out and I don't have moles anymore. The units of my answer are going to have to be grams. But conveniently, the units of my answer are supposed to be grams because this problem is asking me for grams. So convenient. We still need to go back and fill some numbers in though. So let's think about those helpful hints. Green moles is always 1 mole. So I'm going to come down here in my fraction. I'm going to put a 1 next to that mole. And my number of grams is always supposed to be a number from the periodic table. So fortunately for us, this page actually brought the number from the periodic table for titanium forward on the page for us, 47.90. That is your number of grams on the periodic table. We have a name for that. That's called your molar mass. So for titanium, the molar mass is 47.90. Now we just multiply. And again, you can do this in a calculator. You can do this in Google Sheets, whatever you want to do. Use your phone calculator. You're welcome to it, whatever is easiest for you. But when you multiply this out, you should get 220.34 grams of titanium. We have another problem here that we're going to go ahead and try. If you have 4.5 times 10 to the 24th atoms of titanium, how many moles do you have? First, always color code. Look for your color words. I've got atoms right here, which is one of my blue words. I've got moles right here, which is one of my green words. Color code, it's so easy. What an easy first step. It's such an easy step that I actually gave it the number 0 because that step is so easy, okay? Just trying to start in an easy spot. Then you write your given, which should be a number, a unit, and an element over 1. So if you read the problem, find the number they gave you. They gave you 4.5 times 10 to the 24 atoms of titanium. That whole thing is your given. So I'm going to write 4.5 times 10 to the 24th atoms, and then you can abbreviate titanium with its symbol from the periodic table, which is Ti. Write that as a given. You can put it over 1 if you want to. Technically, you don't need the over 1. It's up to you. Whatever makes you feel better. Equally valid ways to do it. Then you decide how many fractions and draw them. If you see the word moles, you need 2 fractions where one of them's your given over 1, and then just 1 more fraction besides that. So I already wrote my given. I need 1 more fraction after that. Easy so far, and again, I know that because I see the word moles right there in the problem. That tells me it needs 2 fractions. Spoiler alert, eventually you're going to need another fraction on top of that, but not today, because if you look, all of the problems on this page have the word moles in it. Lucky you. And we're going to do your next step, which is write the unknown unit and element on top of the final fraction. So if you notice, we already used one of our color-coded words right here, atoms. That's our given. That means the other color must be our unknown. So I'm going to need moles over here. It's always going to switch colors for your unknown. So put your moles of titanium over there. And our final step, what goes up must come down. Again, That's just trying to remind you to simplify your units. So if I have atoms of titanium here, I'm going to want to simplify those units by putting them on the bottom of the fraction where they can cancel out, as they said when I was a kid, or where they can simplify so that at the end, I don't have to deal with atoms anymore because I don't actually want atoms because this question is asking for moles. And I've left myself with only moles because anything that's on top, same on top and on bottom will simplify out. It basically divides to 1, leaving me with moles for my unit, which conveniently means I'm going to have the word moles as my answer, which is convenient because they asked me to find moles, right? That's my unknown. It says right there in the problem, how many moles. That was my unknown, and I'm leaving it as my answer. That's great. I still need to go back in and fill in some numbers though. Anytime you use the word moles, you're going to use a 1. And when it's blue, you use 6.02. So my word moles is a 1. Atoms are blue. Where it's blue, you use 6.02 times 10 to the 23rd. Again, you can divide this on a calculator on your phone, which with the scientific notation is not super convenient, but you can do it. You can use Google Sheets. You can use a TI-84 or TI-83 Plus or like whatever you have. If you have a Chromebook, you can use that Chromebook calculator too. I'm giving you options, but either way, if you're dividing it correctly, you should end up with 7.48 moles of titanium. And go ahead and do one more problem with you. I would prefer for you to pause the video and try number 3 yourself. Actually, not even number 3. We'll say 3 and 1. I'll do 2 more with you. So try number 3 and then example number 2, number 1. Try both of those yourself and then unpause the video, press play, and come back and I'll go back through them. So hopefully if you're watching me say this sentence, you have already tried this for yourself, both number 3 and number 1. And if you have not tried it yourself, what are you doing with your life? I know, that's harsh. Sorry. Bringing down the truth. Okay, color code. Put your given down as the first thing in your problem. If you want to write that over 1, you can. If you don't want to write that over 1, you don't actually have to. You don't technically need it. I'm actually going to kind of do these 2 problems at the same time. So if you didn't do number 1 yet, pause the video and do number 1 also. I want to show you that these steps are universal. They work for every problem in the same order for every problem. So that's why I'm going to do these 2 at a time. For each of them, I color code. For each of them, I find the given number, unit, element. I'm going to label it G for given. That is always going to be the first thing I write. I can write it as a fraction over 1. I don't technically need the over 1. So if you don't like the over 1, if you're too lazy for the over 1, if you understand what you're doing enough that you hate the over 1, like whatever, you don't need it. It's there to help you if that helps you feel better when you put it in the calculator. That's it. Next, you need to figure out how many fractions you need and draw them. So for both of these problems, I see the word moles. If I see the word moles, that means I need given over 1 and a second fraction. I need my given and then I need a second fraction for both of them. And then my next step, once I've written the given over 1, once I know how many fractions, I take the unknown unit and element and I put them on top of the final fraction. So for both of these problems, the unknown is moles. They both say how many moles. For number 3, it's moles of titanium. For number 1 down here, it's moles of aluminum. But either way, my unknown is moles. I'm going to color code that green. Before I forgot to color this gram. Sorry about that. Okay, now what goes up must come down is my next step. And what that means is that I'm thinking about simplifying. I know that these given grams I don't need in my final answer. I know for both of these, my answer is supposed to be moles of the element in that problem. And I know that because the question asked me to find moles. So if my answer is not moles, then I'm definitely doing something wrong. You know what I'm saying? But if I want to get rid of those grams so that I can end with moles, then that means I need to simplify. I need something to be the same on top and on bottom so they can simplify, so they can cancel out. So I'm going to do what goes up must come down, meaning these words that are on top come down to the bottom. These words that are on top come down to the bottom. And that way I know that those words are going to simplify, and then I can stop worrying about grams of titanium in the first problem, and I can stop worrying about grams of aluminum in the second problem. Now, if I look at my helpful hints, my number of moles is always 1, and my number of grams is always a number from the periodic table. So I'm going to come down here. Both of these have a spot for me to write moles, so I'm going to put a 1 there. And then I need grams to be from the periodic table. For titanium, that's easy because that's at the top of our page here. It was already given to us right there, 47.90. Aluminum, it's a little trickier because it's not on this paper. You're going to have to actually look at a periodic table, which is right there, 26.98 for aluminum. So it's different for every element, what number of grams you're putting. Moles will always be 1. If it's blue atoms, when it's blue, you'll use 6.02 times 10 to the 23rd every time, but grams is going to change depending on what element you're looking at. Now you can actually stick these in a calculator. If you're rounding to the hundredths place, these should be the numbers you get. Okay, there are some practice problems for you to work on. So fun, get a move on. And that was a lot, but you can do it. I have faith in you. Good luck.